Hello everyone. Today I'm excited to exemplify a modern, scalable and low latency approach to building data-driven applications. We'll explore how to build in just a few minutes a serverless application integrating Amazon Aurora DSQL, a serverless distributed SQL database that offers high availability and automatic scaling, designed for cloud-native applications requiring high throughput and low latency and high resiliency. AWS Lambda, a serverless compute service that runs code in response to events and automatically manages the underlying compute resources. And Amazon API Gateway, a fully managed service that makes it easy for developers to create, publish, maintain secure APIs at any scale. Our demo will illustrate how these services work together. The API gateway will serve as the entry point, handling HTTP requests and routing them to our Lambda function. The Lambda function will process the incoming requests and interact with the Aurora DSQL database, our persistence layer. The Lambda function will authenticate through an AWS IAM policy, and it will use a PsychoPG adapter, a standard Python connectivity solution for PostgreSQL databases. This is to say, you'll see how our new Amazon Aurora DSQL database maintains compatibility with existing PostgreSQL tools and libraries. And last but not least, Amazon Aurora DSQL will be the layer that stores, retrieves the data, and will show you how quick and easy it is to spin off an Aurora DSQL database cluster. Let's go ahead and get started with creating a cluster. For the purpose of this demo, I'll just create it just to show how easy it is. One click, one cluster, no instance type to choose from, no parameter group to configure. My cluster is now available. I can connect to it either by generating a one-time 15 minutes valid password. This is to be matched with my IAM role, which has the permissions granted to authenticate to this database, to this cluster. Or I can choose to generate my token through the AWS CLI, and in that case I will specify a longer duration, a longer expiry time for my password. So I will say generate me a token valid for 1 hour. I'll store that password in my environment variable, and then I will invoke pSQL as I would with any Postgres database. Now that I'm connected to my newly created cluster, I will create the table where I want to store the results of my Lambda function. And that was it. The database layer is done. Let's go ahead and create the Lambda function. Let's say this is DSQL addition, a Python Lambda function. I would need a layer to include the PsychoPG adapter. If I were to create the layer, it takes a bit of a, I don't know, maybe 1 minute or two. So I won't choose to do that just now, but I will show you what the steps are. I'm attaching all those libraries zipped in a folder suitable for my Python environment, and I just create it. and that was it. But for now, I have my layer already created, and I can just go ahead and add it to my new Lambda function. I'll also need to assign the permissions so that my Lambda function is also able to use the IAM authentication to connect to the Aurora DSQL cluster. So let's go ahead and attach the policy that looks like this. And the permission that I'm interested in this case is the ability to connect to my cluster as admin in this case. We'll keep it simple. Once my role is attached, enhanced with this new policy, I have my layer for the PsychoPG adapter, and I can just go ahead and code. So I'm connecting as admin. As I mentioned, my Lambda function will use this generate db connect admin auth token method. This comes with the Python SDK that is available on our website, and if you want to learn more about it, you can either use the README of the SDK, or you can use this the nice instructions in our documentation. And as I mentioned, all we're doing in this function is inserting the result of two numbers getting added to one another. So let's deploy the code. Let's create a test event. The test event needs to use those two numbers and the cluster endpoint. I will copy my cluster endpoint. Let's give a name to the test event, and let's invoke it. It is successful. And if we check in the Cloud Shell again, in our connection to the database, the addition results should already be there. Let's see. Indeed they are. We are now in the last stage of this demo. We have our cluster, our table, our Lambda function, and we've seen that those three connect to one another. And now let's create an API that will route HTTP requests to our Lambda function. We'll choose a REST API. We'll call it addition. Create a resource, also named addition, with a method get. We'll specify that we want it to connect to our Lambda function. We'll also have to specify the parameters that this API expects, so we'll use the same parameters as we did in our test event for the Lambda function. If you remember, this is where we were testing it. So we're expecting the same parameters in our API. Yes. Now let's deploy the API. Create a stage name, test. We have our URL. And we'll keep it simple and just insert in our browser an API call, and we'll define the first number 345, the second number 476, and the cluster endpoint, which we need to get from the console. Oh, it looks like I made a mistake here. Let's just add the second parameter. And there it is. And if I go to my database connection, I should be able to see this stored in the database. This concludes our demo today. I hope you've seen how easy it is to create serverless architecture with Amazon AWS solutions like AWS Lambda, the API gateway, which effectively routed our request to the Lambda function, which used the PsychoPG adapter to successfully establish a connection with the Aurora DSQL cluster, connection secured by IAM authentication. And of course, we've shown the remarkable simplicity of the Aurora DSQL provisioning. With just one click, we created a fully managed serverless database, no need for complex setup, capacity planning, manual configuration. It's really the minimum time from an idea to deployment.